Good day, everyone. Welcome to this class. In the last class, we were taught on how to simulate a blinking LED. In this class, I'll be teaching you on how to read inputs from a push button. If you remember in the previous part where we talked about electronics, we mentioned that there are different types of electronic devices, which are the inputs and the output device. Now, what are the output devices? Output devices that are devices that simply uh, gives out a result like an LED bringing out light and the rest. While an input device are devices that gives in signal into your microcontroller or your microprocessor, whichever they may be. So that is what an input device is. An example of such devices are the push button. This is a typical push button that has 4 terminals. In some cases, you might see push button that has 2 terminals. So how do you work with them? So in the 2 terminal, what you do is to connect one to the signal and to the digital pin, any of the digital pin, and you connect the other one to the ground, then you read. But in the 4 terminals, you have to find something. You have to look for terminals that are connected together. Now, how do you do that if you're not using your Tinkercad? Now, Tinkercad has made it easier that you can see that here's 1B and 1A. So you can know that this one is related to this one. That means they are connected together, and 2A to 2B. But if you can't, if you're not using your Tinkercad and you're using the real components, what you do is if you have a multimeter, you switch it on to the connect to what we call the continuity mode. Then you test. You put one of the probes here, the other probe here, and if you hear a blink, you know that they are connected together. A beep, you know they are connected. But if you don't hear, you know that they are not connected together. So the pins you took note of that are not connected together, that is where you connect your wires to. But but in this case, we have already seen the pins that are connected together and the ones that are not the ones that are not connected together, which makes our work very, very easy. Also, in if you're using a real component, you can just connect it across. That is another easy way of doing it. If you connect it across, you're very sure that you're not making any mistake. So we're going to be doing that now. We're going to connect our device. So from here, let's take a ground. Now we can now take here from 2A ground. Now from 1B, let's put it red. Let's say we are working with digital pin 7. Okay, now let's get into the code. Now, just like we did in the previous class, we will declare the pin we've connected our push button to, and we'll have to assign a name to it. So we'll call it button just for short. We don't need to write push button to be too long and tedious to do. So let's use button. Remember, it was connected at pin 7. So the next thing we're going to do, we're going to introduce the pin mode so that we can classify the device as an input device. So button, comma, input. Now, for us to read the signal coming in from the push button, we will need to use what we call the serial monitor. This is the serial monitor. So what happens is that right now the serial monitor is not active. So in order to make it active, we will have to introduce a function called serial.begin, and we'll have to, inside the serial.begin, we'll have to put a, a speed rate or the data processing speed rate of this microcontroller. So let's do that now. Go to the next line. So we introduce the key function serial. Please take note of the async. Dot begin. You open and close brackets or semicolon to end every line of code. So this is it. Now what this does is that it activates your serial monitor, and this value inside there is the rate at which signals are being transmitted. So you have to specify the value. If not, it will not read correctly. So this is it. We've introduced it. So the next thing we do is to go into the void loop. Remember that we want to read a signal from our push button. So we have to introduce another keyword called the digital read, which enables us to read signals on our serial monitor. So let's start that digital read. Digital read 7. Can you see that? So this function enables us to read whatever signal is flowing in from the push button. You can as well write button here. You will still get the same results. So the next thing we're going to do is very simple. We'll have to print out whatever we get from this on the serial monitor. So in order to do that, we'll have to introduce another function called serial.print line. Serial dot print line, short for LN. So this is how it is written. You don't need to write the line in full. It won't work. So this is a special keyword. So always take note of that. Then we can copy this, then place it inside here. Control. Now take note of what I did. I took the whole of that digital read and put it inside the bracket of the serial.print line. There's another easier way to do that, but you have to know this before we bring out that other method. So right now, we've set up our code and everything. So let's see what's going to happen. Now, you see, it's reading at a very fast rate, which we don't want. So we'll close it down. Stop simulation so you can edit your code. So we'll add a delay so that we can read. There's a delay for 1 second. We'll be able to see what's happening. Let's start simulation. So you can see it's clear. So it's ready. But now let me make something clear. Tinkercad has a limitation in the sense that it cannot detect what we call noise coming from the push button. Now, a push button is a device, it's an input device like I stated earlier. Sometimes uh, when you try to read for some pins, the pins try to emit what we call noise into the push button and thereby causing the serial monitor to read uh, incorrectly. Now let me show you what I mean. So we'll go to the main code. I've already connected everything we need together. This is your Arduino IDE, the specified ID for your Arduino board. So we're going to see what is actually reading here. And delay first. Okay, we'll upload the code now. So with this, you'll be able to see the irregular reading. It's supposed to either read high or low, depending on the case. Okay, let's look. You can see 001, 001, 1, 000. So you can see that it's reading at an irregular rate. So all this is as a result of noise coming in from the input pin you put in, trying to clash with the signal pin that you are getting from your button. So we don't want this kind of scenario. So in order to do that, we have to correct the situation. How do we do that? And let's go back to the code. Close. So we have to take a resistor. We'll move this up. Then we rotate this. Let's see if we can move this, take this here. Then we'll also ground red again. We'll subject this to 5 volts. So from here back to here. So just please don't be confused. We took the 5 volts from here, then we transferred it. Sorry, the connections are wrong. Let's just take the 5 volts from here. This should be okay. So we took 5 volts, connected the wire from 5 volt to this place. So what we just did now is we'll call it, this resistor here is called a pull-up resistor, and the rating has to be 10 kilo ohms. So what happens is that any of the noise coming in, it takes it off and pushes it to what? 5 volts. So let's see what happens. Open your code editor. So you can see it's reading 1, 1, 1, 1, 1. So same with our, let's go to the main algorithm code. I'm going to introduce the pull-up resistor now. Okay, let's see what happens. You can see it has changed. So what happens is that the resistor, you've used the resistor to suck up all the irregular reading. So now let's see what happens when we push the push button. Okay, let's take, you can see 0. So this is how it's supposed to be. When you push it, 0. When you leave it, 1. So there's another configuration of this resistor called the pull down, and in that case it will be reading 0 initially, then when you press it will be reading 1. So this is how to correctly connect your push button to avoid noise. So we'll be stopping here for now. See you in the next class.